Okay, this is lecture 16. I will have 4 videos for this one, each with one example. So these examples are a little bit more involved, but there are only 4 of them. So first of all, let's say that the Mars Candy Company was getting ready to introduce the blue M&M. In their marketing meeting, they began to explore pricing for the new promotion. If brown M&Ms cost $2.25 per pound and blue M&Ms cost $6.75 per pound, how many pounds of brown and how many pounds of blue should they mix to get 300 pounds of a mixture that would sell for $4.05? Now, first of all, I would love to find M&Ms for $2.25 a pound, but anyway, we'll just ignore that part. Okay, what we want to do here is the same thing that we did in the last lecture, but we're just going to make it a little bit more explicit again. We have our per, amount, and subtotal. Do you remember that chart? Does it look familiar? We didn't use it extensively last time, but we're going to use it throughout lecture 16 and 17. In chapter 17, it will have a slightly different form, but it will still be the same idea. So our per, our amount, and our subtotal. Our per will be something different for every problem. Here, my per is my cost per pound. So if I have brown M&Ms, blue M&Ms, and then my mixture, my cost per pound would be $2.25 for brown, $7.65 for blue, and $4.05 for the mixture. So my per is my cost per pound, and it goes in the per column. Now the amount. I don't know how many pounds of brown and how many pounds of blue, but I do know that I have 300 pounds of the mixture. So I'll have X and Y, and then 300 for the total. Now my little subtotal column over here on the right-hand side. If I take per times amount, do you remember when we did this before with the shopping, with the cost? Per times amount gave me the subtotal. So if I take $2.25 per pound times X pounds, that obviously gives me 2.25 times X, but what does that number mean? What that number really means is 2.25X is the amount of money that the brown M&Ms in the mixture are worth. And because we have my cost per pound times my number of pounds. It's just like we're going shopping for soup like we did in lecture 15, where we got 9 cans of soup for $1.50 each. Here we're getting X pounds of M&Ms for $2.25 a pound. So the total amount we're spending on brown M&Ms is 2.25X. The total amount we're spending on blue M&Ms is 7.65Y. And the total amount we're spending on the mixture is 4.05 times 300. I want you to just take a second, and since this is your first example, it might be hard to see the contrast. But that 4.05, I want you to see why it belongs in the per column and not in the total column. That 4.05 was a cost per pound. It was not a total cost. So if I have 4.05 per pound, I'd multiply it by 300 pounds to get 4.05 times 300, whatever that turns out to be. So I've got the first third down. I've got my information organized into my chart. That's my first third. Make sure that makes sense before we go on. Okay, the next part is we are going to get 2 equations out of here somehow. Now, it probably looks obvious, maybe, to see where those equations would come from, but let's see if they really make sense. Would X plus Y really equal 300? Well, I hope so, because X is how many pounds of brown, Y is how many pounds of blue, and 300 is the total number of pounds. So X plus Y equals 300 really should make sense. Now, the last column looks like it should give me my other equation, but let's see if it makes sense. That 2.25, remember what that number is. It's the subtotal for brown. That's how much all the brown M&Ms are worth. The 7.65Y, that's how much all the blue M&Ms are worth. So we have the subtotal for brown, the subtotal for blue, and the grand total for the mixture. So it actually does make sense to add both the middle column and the right-hand column. So we've got our second third. First third is getting the chart. Second third is getting the equations. Again, make sure the equations make sense before we go any further. Okay, now we want to solve this. Would we do substitution or elimination? This one's a toss-up. Easy to solve for an X or Y in that first equation. Easy to do substitution. It's also pretty easy to see how to get one of those variables to cancel. So let's do elimination on this one. So just for fun, I'm going to eliminate my y's, but I could just as easily have eliminated my x's. So if I multiply that top equation by negative 7.65, then I'll have negative 7.65x minus 7.65y equals negative 2295. Now I'm going to add the equations together. Negative 7.65x plus 2.25x will give me negative 5.4x. My y's canceled just like I hoped, and my number on the other side will be negative 1080. Now to solve for x, I'll divide both sides by negative 5.4 and we get x equals 200. Okay, plug it into either equation, but the first equation is the easiest, and we'll get y equals 300 minus 200, or 100. So my answer would be that I have 200 pounds of brown M&Ms and 100 pounds of blue M&Ms. That is our first mixture problem, and we will do the second one in the next video.